Hi everyone, today we're in day 2 of our section 5.5, which is multiple angles and different formulas, and we have another formula to talk about today, which is called the half angle formulas. And hopefully it's kind of obvious why they're called the half angle formulas. You're taking half of every angle here. U divided by 2 is in every single one of these formulas. So these are the 3 formulas that we will be using for sine, cosine, and tangent, and you can see that tangent has 2 different formulas. You can use either one, it really doesn't matter. All right, so the half angle formulas are kind of used just like the angle sum and difference identities were. 105 is kind of an oddball angle. It's not on the unit circle, but they're asking us to find the exact value, so that means they don't want the decimal approximation from the calculator. I realize that you could use an angle sum and difference identity for this, but the half angle identity just gives you a different option. So what we are going to do is try to find the cosine of 105 degrees, and we're going to be using the half angle identity. So what we want to do is figure out what the cosine of what angle divided by 2 would be to give us the same thing as 105. Well, if I double 105, I get 210. And 210 divided by 2 would give me 105. So that's the combination that we want. And 210 happens to be a unit circle value. So that's perfect for our formulas. The cosine of our half angle is plus or minus the square root of 1 plus the cosine of u, this is our u, 210, divided by 2. All right, let's deal with the plus or minus first. First of all, we are actually finding the cosine of 105. That's what we're finding. Well, 105 is in the second quadrant. And we know that everything in the second quadrant with regards to cosine is negative. So that means that we don't have to worry about the plus or minus. We know our final answer is going to be negative. Carrying on with this problem, we also know that the cosine of 210 degrees, being in the third quadrant of the unit circle, is equal to negative square root of 3 over 2. So we're going to make that substitution into our problem, and now we need to do some simplifying. On top, we need to turn this 1 to have a common denominator with the 2, so that's going to turn into a 2. So we have 2 minus the square root of 3 all over 2, all over 2. If I reciprocate and multiply or just kind of move this 2 into the denominator, I get a 4 down there. So now I have 2 minus the square root of 3 all over 4. And if I take the square root of the top and the bottom separately, I have the square root of 2 minus the square root of 3 all over the square root of 4, which is 2. And that would be your final answer. And if you put this into your calculator and got a decimal, and you put all of this into your calculator and got a decimal, you should get the same decimals for both of these answers. It's fine that we have a square root under a square root. That's totally fine. Don't worry about that. Next problem has us solving again on the interval from 0 to 2 pi. Remember we talked about yesterday that we don't want to include 2 pi in our answer. We would just look from 0 up to 2 pi. And if you look at this one, the funky thing going on here is the same thing we talked about yesterday. We have 2 different angles going on in the problem. We also have 2 different trig functions, but we'll deal with that later. We got to get the angles to be the same or we can't do this problem. So luckily, I see a half angle here. This is the same thing as saying the sine of x over 2 squared. So we are going to go to our half angle identities, and for the sine of x over 2, we're going to plug in the formula, which is plus or minus the square root of 1 minus the cosine of x divided by 2. Now, that whole thing is squared, which is a good thing. Because if you square a positive, you get a positive. If you square a negative, you get a positive. So this plus or minus is taken care of thanks to our square. So it's gone. It's just going to be positive. Then you're also squaring a square root. Well, when you square a square root, that's gone. So this squared took care of a whole lot of things for us right now. And so now we have 1 minus the cosine of x over 2 on this side. And over here, I still have my cosine squared of x. Just by substituting in that identity, we have now both of our angles are single angles, and we have all cosines. So this is kind of a good thing. We got to get rid of the fraction over here. So we are going to multiply both sides by 2 or cross multiply, whichever way you want to think about it. So now this is 2 cosine squared x equals 1 minus the cosine of x. and it's quadratic. We're going to get everything on one side. This is 2 cosine squared x plus the cosine of x minus 1 equals 0. And since this is a quadratic, we're going to factor it with a little AC plus B. This is the exact same equation as yesterday. So this factors to 2 cosine of x minus 1 and the cosine of x plus 1. And then you're going to set these equal to 0 and solve. So we get the cosine of x equals 1/2 and the cosine of x equals -1. Sorry, my pen's being a little funky there. And now you got to figure out where around the circle does cosine equal 1/2. Well, that would be at pi over 3 and 5 pi over 3. And where does cosine equal -1? That would be at pi. So those would be your 3 answers. Third type of problem, we did these types yesterday and we did them with angle sum and difference identities. They want you to find the equations or the values for the sine of u over 2, cosine of u over 2, and tangent of u over 2. And they gave us this given information for the secant of u. So to start out with the sine of u over 2, let's look at that formula and see what we need. So we have plus or minus 1 minus the cosine of u divided by 2. Okay, so we need the cosine. And they're telling us the secant is right here between pi and 3 pi over 2. So that's actually a third quadrant triangle. And for this one, I guess you really don't have to draw the triangle yet, but I'm going to just so we have it done. So the secant is going to be 7 over a -2. And if we do our Pythagorean theorem, this is going to be 49 minus 4, which is going to be the 45 square root of 45, which is equal to 3 square roots of 5. And since this is in the third quadrant, it's -3 square roots of 5. All right, back to this. So we know the cosine is -7 over 2. So that means, I'm sorry, the secant is -7 over 2. So that means that the cosine is -2 over 7. So I am going to plug in here 1 minus -2 over 7. And we got to clean this up. So we clean it up and this becomes addition, and we're going to add 7 over 7 to 2. So this is 9 over 7 divided by 2 over 1. So if we reciprocate and multiply, this is the square root of 9 over 14. And so this would be 3 over the square root of 14, or 3 square roots of 14 over 14. Okay, now it's time to make our decision about this plus or minus we've been carrying along. You're taking the sine of u divided by 2. Well, we know that u is in the third quadrant. So u divided by 2 would be all of these things here divided by 2. So u divided by 2 would be between pi over 2 and 3 pi over 4. And pi over 2 and 3 pi over 4 is right here in our second quadrant. So u divided by 2 is in the second quadrant. Well, sine's positive in the second quadrant. So my final answer for this one's positive. Second problem, we got the cosine of u over 2. So we have plus or minus the square root of 1 plus the cosine of u over 2. So it's pretty much the same thing, only this time we have a plus. So we have 1 plus a -2 over 7 divided by 2. And so on top we get 5 over 7 divided by 2. And so this would be the square root of 5 over 14. Still got the plus or minus out there. We'll talk about that in a second. This is the square root of 5 over the square root of 14. So we have to rationalize that. It's not pretty, but that's okay. 5 times 14 is equal to 70. And then we would just get 14 on the bottom. And it's time to think about the plus or minus. Okay, back up here, we said u divided by 2 is in the second quadrant. Well, cosine's negative in the second quadrant. So this final answer is going to be negative. And then for our third answer, we have the tangent. In the tangent formula, you got 2 to deal with, the tangent of u over 2. I'm going to use the first one. It really doesn't matter. 1 minus the cosine of u over the sine of u. Well, we know 1 minus the cosine. The cosine was -2 over 7. And the sine we need from our triangle, which is -3 square roots of 5 over 7. So we get our common denominator up here. We got 9 over 7 over -3 square roots of 5 over 7. Our 7s are going to cancel. The 3 is going to go into our 9. And right now we have 3 over the square root of 5, which we will rationalize that. And that gives us negative 3 square roots of 5 over 5. And that's our final answer. We don't have to worry about a plus or minus because there was no plus or minus in the formula. It comes out in the equation. Think about it. We just said we were in the second quadrant. I don't know if I can go back up there. I kind of don't have any room. Will it let me go up? I can't get back up there. But we were in the second quadrant. It should make sense that tangent is negative. And to double check yourself, you have, oh, isn't that wonderful? You have sine over cosine to compare. So the 14s would cancel. You have a positive divided by a negative, which would give you a negative, and you could clean up the square root of 70, and we should get negative 3 square roots of 5 over 5. All right, so that's it for our half angle identities. They're not nearly as meaty as the double angle identities. And I want you to try your homework on these. I will post the answers, and you will have a little quiz on this tomorrow.